In reading 1.1, we mentioned two specific flavors of forces, weight and normal force. In our last lab, we derived an equation for the weight of an object, Fw equals gm, where g is the local value for the gravitational field strength. Now we are going to come up with an equation for the normal force. We know that a bathroom scale measures normal force exerted on an object by the floor. If the floor is horizontal and flat, and the object on the scale is isolated, then the reading on the scale is equal to the object's weight. What happens if the floor is not level? We can test that by placing the scale on a stiff board and taking measurements as we tip the board. Here's my experimental setup. I put the scale on my desk next to my computer to make this easier. Here's my test subject, a large iron block. I'm going to put the block on the scale and see what happens. The scale tells me how hard the desk is pushing up on the block. Next, I'm going to lift up one side of the scale and record the output from the scale on the computer simultaneously. As we tip the board, the reading on the scale goes down. The only thing that we are changing on purpose in this scenario is the angle of the ramp. The normal force supporting the block must depend on the angle of the ramp. Before we can pick a math model for normal force, let's think about special cases that we are sure about. When the angle is 0 degrees, the normal force would be equal to the weight, Fw. If the angle is 90 degrees, no part of the ramp is supporting the block, and the normal force would be 0. As we saw with our bathroom scale experiment, if the angle is between 0 degrees and 90 degrees, the scale reads a value in between 0 and the weight of the object. Here's a brief trig table with the basic trig ratios. Which trig function matches the behavior of normal forces on ramps? The cosine table matches. It gives an answer of 100% at 0 degrees and 0% at 90 degrees. This means we can write our math model for normal force as normal force equals weight times the cosine of the angle of the ramp. Or we could use the mass and weight lab result to write it as normal force equals gm cosine theta.